In this lesson, we will identify identity and inverse matrices. So the identity matrix is essentially just a square matrix as a diagonal of ones and all of the other elements are zeros. That should look familiar to us as when we were solving using Gauss-Jordan elimination. The left side was essentially the identity matrix where we had 1, 0, 0, 1, etc. So a diagonal of ones. If you multiply a matrix by the identity matrix, you should get your original matrix back. So let's verify that real quick. Notice that I'm going to do it in both orders, and either way I should end up with my original matrix A back. So if I take 4, negative 2, that would give me 4 times 1 plus negative 2 times 0, which is 4. And then 4 times 0 plus negative 2 times 1, which is negative 2. And then I would take my 3, 0 and do the same thing. So 3 times 1, which is 3, plus 0 times 0. And then 3 times 0 plus 0 times 1, which is 0. So notice in that order, yes, I did get my original matrix A back. Now let's do the same thing in the opposite order. So 1, 0. That gives me 4 plus 0, which is 4. And then negative 2 plus 0, which is negative 2. Replacing that with 0, 1, that gives me 0 plus 3, which is 3, and 0 plus 0, which is 0. So notice each term, or each way that I do it, each order, I do end up back at my original matrix A. To determine if two matrices are inverses of one another, we simply have to multiply them in either order to determine if we end up with the identity matrix. So if I'm multiplying matrix A by matrix B, hopefully I end up back at the identity matrix. Of course, I'm going to end up with a 2 by 2, and I'm hoping that that's going to be 1, 0, 0, 1. So first I'm going to think of negative 5, 2. Negative 5 times negative 1 fourth is positive 5 fourths, plus 2 times negative 1 eighth, which is negative 2 eighths, or negative 1 fourth. Negative 5 times negative 1 fourth is positive 5 fourths. And then 2 times negative 5 eighths is negative 10 eighths, which is negative 5 fourths. Then I'm going to do the same with 1, negative 2. So 1 times negative 1 fourth plus negative 2 times negative 1 eighth, which is 1 fourth. And then 1 times negative 1 fourth plus negative 2 times negative 5 eighths, which is 10 eighths, or 5 fourths. So if I simplify that, this ends up to be 4 fourths, which is 1. These two are opposites, that's 0. These two are opposites, that's 0. And these two are 4 fourths, which is 1. If I did it in the opposite order, I should also end up at 1, 0, 0, 1. So in this one, I want you to determine if these two are inverses by checking to see if their product is the identity matrix. So 4, 3, 13, 10, multiplied by 10, negative 3, negative 13, 4. We're going to multiply. So I'm going to turn 4, 3 into a column. That gives me 40 plus negative 39, and then negative 12 plus 12, and then I do the same thing with 1310, which gives me 130 plus negative 130, and then negative 39 plus 40. So simplifying each of those, that gives me 1 and 0 and 0 and 1, so they are in fact inverse matrices.